Assalamualaikum and hi everyone. This is the second part of our basic probability concepts topic. Now let's talk about two really important rules of probability, and they're super intuitive once you think about them. First, the probability of any event is always between 0 and 1. 0 means it's impossible, like rolling a 7 on a regular 6-sided die. Not gonna happen. 1 means absolutely certain, like flipping a coin and getting either heads or tails. One of those has bound to happen. So probabilities are like confidence levels. You can never go below 0 and you can't go above 1. Second, if you add up the probabilities of all possible outcomes, they will always equal to 1. Let's go back to that die. You can roll a 1, 2, 3, 4, 5, or 6. Each has its own chance, but if you add up the probabilities of all those 6 outcomes, the total is exactly 1, because one of them will happen. Simple, right? These two rules help keep everything balanced and logical in probability. Nothing falls outside that range. The special rule of addition is used when two events cannot happen at the same time. These are called mutually exclusive events. For example, you cannot roll a 2 and a 3 at the same time on a single die roll because it's impossible. So if you want to know the probability that either one event or the other will happen, but not both, you just add their individual probabilities. Now let's go through the example. You roll a die. What's the probability of rolling a 2 or a 3? The probability of rolling a 2 is 1 out of 6. The probability of rolling a 3 is also 1 out of 6. Since they are both mutually exclusive, we add them. 1 over 6 plus 1 over 6 gets you 2 over 6, which is 1/3. Let's take a look at another example. You have a fruit basket with 3 apples, 2 oranges, and 4 bananas. What's the probability of picking either an apple or banana? First, find the total fruits. 3 apples plus 2 oranges plus 4 bananas gives us 9 fruits in total. The probability of apple is 3 over 9. The probability of banana is 4 over 9. Let's add them together. So the probability of getting either an apple or a banana is 7 over 9. Remember, this rule only applies when the two events cannot happen together. So they are either-or situations. Sometimes two events can happen at the same time. They are not mutually exclusive or overlapping. The general rule of addition accounts for this overlap. Here's the simple formula. Probability of A or B equals to probability of A plus the probability of B minus probability of both A and B. We call this last part the joint probability. Let's take a look at our example. A survey of 200 visitors at a theme park revealed that 120 went on the Ice Age roller coaster, 100 went to the haunted house, and 60 visitors did both. We want to find the probability that a visitor went to either the Ice Age roller coaster or the haunted house. First, we find the probability of going on the roller coaster, which is 120 over 200, which gives us 0.6. Then we find the probability of going to the haunted house, which is 100 over 200, which gives us 0.5. Finally, the probability for going on both roller coaster and haunted house equals to 60 over 200, which gives us 0.3. Now we apply the formula. The probability of going on the roller coaster or haunted house is 0.6 plus 0.5 minus 0.3, which gives us 0.8. This subtraction is important because the 60 people who went to both places were counted twice, so we remove one count of that overlap. In short, the general rule of addition helps avoid double counting when events can happen together. Now let's take a look at the complement rule. The complement rule in probability is figuring out the likelihood of something not happening when you know the chance of it happening. Here's a simple way to think about it. If there's a 30% chance of rain during a visit to Tioman, the chance of it not raining is 1 minus 0.3, which gives us 0.7 or 70%. This works because in probability, the total chance of all outcomes which includes something happening or not happening, always adds up to 1 or 100%. It's a handy shortcut. Moving on to the special rule of multiplication. The special rule of multiplication is used when two events are independent, meaning the outcome of one event does not affect the other. In these cases, to find the probability that both events happen, you multiply their individual probabilities. Let's take a look at our example. A survey by AAA revealed that 60% of its members made airline reservations last year. Now, if you pick two members at random, what's the probability that both made airline reservations? Here's how we calculate it. Probability the first member made a reservation is 0.6. Probability the second member also made a reservation is also 0.6. So the probability that both made reservations equals to 0.6 times 0.6, which gives us 0.36 or 36%. This is like saying if you have a 60% chance of success on one event and another 60% chance on an independent second event, the combined chance that both happen together is 36%. The general rule of multiplication is used when two events are dependent, meaning the outcome of the first event affects the second. The formula is probability of A and B equals to probability of A times the probability of B given A. We call this second part of the formula the conditional probability. Let's go through the example. A golfer has 12 shirts in his closet, 9 white and 3 blue. He picks a shirt at random in the dark and wears it without laundry. On day 2, he picks another shirt from the same closet. So what is the chance or probability that both shirts selected are white? Okay, so the first pick is the probability of white, say, which is 9/12. After the first pick, there are 8 white shirts left, and the total number of shirts is now 11. So the probability of the second pick being white is 8/11. To find the probability that both shirts selected are white, we multiply 9/12 times 8/11, which gives us 0.55. This shows that the first selection affects the second because the shirt was not replaced, making it dependent. Conditional probability is the chance of one event given that another one has already happened. For example, if 60% of students pass a test and 40% of those who pass also did extra credit assignments, then the probability that someone who passed the test and also did an extra assignment is 40%. Joint probability tells us what's the chance of two things happening together. For independent events, we multiply their probabilities. For dependent ones, we use conditional probability. Remember, joint probability is used when events are not mutually exclusive or overlap. You may try these exercise questions and check your answers in the file uploaded in the class website.